Hi everyone, in this video we're going to work on composing trig functions and inverse trig functions. So sometimes the result will be fairly trivial and other times it gets a little bit tricky, and I love this for a couple of reasons. One is that we have to think our way through some of these compositions in Calc 2. The other is that it really makes you think extremely carefully about what each of our trig functions and inverse trig functions do, what they input, what they output. Okay, so, oops, sorry for the wobble. First one, inverse sine of pi over 6. So really the first thing that I'm hoping here is just that you remember that when you compose inverses, you should get back what you started with. So I'm hoping that we all have a pretty, excuse me doing these at night. Okay. When you compose a function its inverse, you should get back what you started with. So I'm hoping that we have a guess at least that we should be getting pi over 6 here. We do have to be a little careful. We have some pretty hefty restrictions on what inputs of sine we allow for the inverse thing to work, and consequently what outputs of inverse sine we allow, what arc lengths we allow it to give us back. So here we can even walk through and actually do the steps. I don't know that we have to, but just to make sure that we're being really careful. This is sine pi over 6. So pi over 6 is an arc length. That's what sine inputs. When I take the sine of pi over 6, I get back my y value, which at that point will be 1/2. If I then take 1/2 and plug it into inverse sine is going to say, oh, you're giving me y value 1/2, which is great because that's exactly what I was thinking when I got it out of sine. My y value is 1/2. And then inverse sine should tell me the arc length between negative pi over 2 and pi over 2 that does that. So I'm saying if my y value is 1/2, and I'm choosing the point on this side, what is my arc length? And it is in fact pi over 6. So it does work as expected here. When you compose a function and its inverse, you should get back what you started with. But again, there can be exceptions to this when we violate domain restrictions and things like that. Okay, so next one, I want to take the tangent of the inverse tangent of -1. So once again, I'm sort of ahead of time predicting in my head that it's going to be -1, but I can walk through really carefully. So if inverse tangent is getting the -1, inverse tangent will immediately assume that the -1 is a slope. Once it gets that slope of -1, it's going to output an arc length between negative pi over 2 and pi over 2. So if I'm thinking about being on the unit circle with a slope of -1, I could be in quadrant 2 or 4. That negative pi over 2 to pi over 2 restriction is going to force me over here. And specifically, I'm right smack in the middle, so it's going to give me negative pi over 4. So I say, if my slope is -1 and I find my arc length, and then I give my arc length to tangent and try to find my slope, what do I get back to? And it should in fact be -1 again. So still no weird problems. I swear they're coming, but none so far. Okay. Arc cosine of 5 pi over 4. So here I'm saying, okay, if I'm inputting it into cosine, the 5 pi over 4 is an arc length. So I'm picturing that I've gone 1, 2, 3, 4, 5 pi over 4. So I'm sitting in quadrant 3. I then take cosine of that arc length. Excuse the yawn, which is a -1 over root 2. Okay, so far I've said if my arc length is 5 pi over 4, my x-coordinate is -1 over the square root of 2. The next thing I'm supposed to do is decide what my arc length is if my x-coordinate is -1 over the square root of 2. But you want to be really aware of the fact that even though arc cosine and cosine are sitting here right next to each other, they're not communicating at all. So arc cosine isn't thinking, wow, we started at 5 pi over 4 to get this arc length. It's just thinking my x-coordinate is -1 over the square root of 2, which means I'm either in the middle of quadrant 2 or 3. Because I'm arc cosine, I'm going to throw away quadrant 3 and I'm going to say, okay, this is my point right up here in the middle of quadrant 3, and I want to pick the shortest possible arc length to get me there, which is a 3 pi over 4. So here's our first case of failure to communicate. Arc cosine and cosine are not actually inverses if you're working with an arc length that's not between 0 and pi. So if at any point you're picking up arc lengths that aren't in 0 to pi, you're in a little bit of trouble. It's doable. It's not that we can't do it. It's just that they're not inverses. So really what we ended up saying here is which arc length between 0 and pi will give you the same x-coordinate that you'd get with an arc length of 5 pi over 4. So we found the arc length that gives us the same x-coordinate that we had at this point. Okay, sine of arc sine of 1/2. So again, I kind of tentatively want to think that I'm expecting 1/2, but I want to be really careful because the trig functions and the inverse trig functions can be a little tricky. So I am inputting the 1/2 into arc sine, which means it's a y. So first question is, if your y coordinate is 1/2, what arc length between negative pi over 2 and pi over 2 did you use to get there? So I'm going to use this one, which is a pi over 6. Okay, so in here I have a pi over 6, and then I say to myself, so completely new start on this thing, if my arc length is pi over 6, what is my y coordinate? So this one is another one that works perfectly well. So let me think if I can talk through that one nicely. Find your y value if you're at the end of the arc length between negative pi over 2 and pi over 2 that makes your y coordinate 1/2. So you can see there that I hope that the restriction on angles didn't really make a difference. We were starting with a y value of 1/2 and we were asking what y value we would end up at, and since nothing in that process moved us to a new point, we're still going to have a y value of 1/2. Okay, let's see. So we want to look at a cosine of an inverse cosine of a square root of 2. So the square root of 2, since I'm plugging it into inverse cosine, that's an x value. So I'm saying if my x value is square root of 2, what is my arc length? And this is one of those, again, that's undefined. We can't even actually make it to that second step. So just think carefully, right? It's really tempting to say cosine of inverse cosine of square root of 2 is square root of 2. But if this inner question doesn't even make sense, you can't do that. And also, if you get anywhere outside of those negative pi over 2 to pi over 2 or 0 to pi restrictions, it's not going to work there either. So this doesn't make sense because the very first question is, if my x value is the square root of 2, which is way out here somewhere, not in the reach of the unit circle, what is my arc length? And the answer is you can't ever get there, so you don't get an arc length. Hi, kitty. Okay. What about inverse tangent of 11 pi over 8? Okay, so once again, I'm seeing those inverses. I'm hoping to get 11 pi over 8. I do have to be careful. So if we say, all right, this went into tangent first, so it's an arc length. If I go 11 pi over 8, let's see, 8 pi over 8 lands me right here. And then pi over 8, okay, so we're splitting the top half up into 8, which means each quadrant is getting split up into 4. So if we go 1, 2, 3, so even parts there. So this is a pi over 8, a pi over 8, a pi over 8, pi over 8. So 11, so we need 8, 9, 10, 11, which puts us really far down in quadrant 3. Okay, so here's the thing, that's not a special value. So I'm supposed to be saying, okay, what is my slope? And then after I figure out my slope, I'm supposed to be plugging it into inverse tangent, at which point my question will be, given this slope, what is my arc length? So this is actually a really good one. It starts off looking like it's fairly simple, but it gets really tricky. So because it's not a special value and I can't just walk my way through, I have to think about this really carefully. So if I ask tangent for the slope, it's going to give me the slope of this line, right? But this line could actually have come from starting in quadrant 1 at this point or in quadrant 3 at the point we were actually at. So when we give the slope of this line, I'm just going to call it m. So this is a y equals mx plus b is 0, so just that. So I would get my m, and then I would give m to inverse tangent. I would say, okay, if this is my slope, so basically if I'm on this line, what arc length are you going to give me? An inverse tangent is never going to make it around to quadrant 3. It's going to say, okay, well, the shortest distance to get to that point is right here. And if we can see some of our symmetry straight across through the origin, this has to be 1, 2, 3 pi over 8. So the answer here will be a 3 pi over 8. So again, a little bit of symmetry in the mix for that one. I really like that one. Okay, so we have been pretty consistently sticking with composing a trig function and its own inverse. And I want to start looking a little bit about what happens if you compose inverse trig functions with other trig functions that are not necessarily their inverse. So the first one I've got here is a sine of an arctangent of 1. So again, trying to make things not too crazy. We're going to have some of these where you can actually walk through step by step, but really think about what's happening and about the picture here. So arctangent of 1. If I'm looking for arctangent of 1, I know the 1 has to represent slope. So tangent inputs arc lengths, outputs slopes. Arctangent inputs slope, outputs arc length. So here's a slope of 1, and I could be in quadrant 1 or 3. Because it's arctangent, it will decide that I have to be in quadrant 1, and it will try to find this arc length for me, which ends up being a pi over 4. So I get an arc length, that's my pi over 4, and then I plug that into sine. And especially when you're composing trig functions with inverse trig functions where they're not each other's inverses, so arctangent with the sine or arcsine with the tangent or any of those sort of things, you want to be careful about thinking about if what you're plugging in is still what you thought it was. So we thought pi over 4 was an arc length, but will sine think about it as an arc length? And the answer here is yes, but that's a good thing to start watching out for. So sine does input arc lengths. What sine will output is your y coordinate. So at this point right here, my y coordinate is 1 over the square root of 2. So that's my answer. So really what's going on here is I'm saying if I'm sitting with an arc length somewhere between negative pi over 2 and pi over 2, so on the right half of the circle, my cat's invading, excuse me. If I'm sitting between negative pi over 2 and pi over 2 on the right half of the circle, and I have a slope of 1 connecting my point to the origin, can you tell me my y coordinate? That's what's really going on here. Given a slope, can you give me a y coordinate with the restriction that you have to be over here? Okay. Another one, let's see. Cosecant of inverse cosine of root 3 over 2. Okay, so for this one, we start with this root 3 over 2, and since it's the input for an inverse cosine, it's my x value, which means I'm out here looking at a point close to the x-axis in quadrant 1 or quadrant 4. Because it's an inverse cosine, it will automatically pick this point in quadrant 1, and it will go looking for this arc length. And once again, we can actually find that arc length. So the arc length here should be a pi over 6. So arc cosine outputs the arc length pi over 6. Cosecant should input that arc length and still be looking at it as an arc length. That's what cosecant does with whatever you give it. It assumes you're giving it arc length, and it gives you back 1 over your y coordinate. So if we think about coordinates on this point, the x is root 3 over 2, the y is 1/2, which means cosecant is positive 2. Okay, so that was the step-by-step, but again, it's really good to take a step back and look at big picture here. So big picture, what I'm being asked to do here is to say, okay, I'm sitting on the unit circle with an x-coordinate of root 3 over 2. I'm assuming I'm on the top half between 0 and pi arc length, and I am supposed to figure out what the reciprocal of my y is. So given x value root 3 over 2, what is the reciprocal of your y value? Okay, let's see. Almost gone through all my colors. Let's try out yellow. I think I remember that I didn't end up liking yellow though. Okay, so inverse sine of cosine of 4 pi over 3. Okay, so 4 pi over 3, if I'm inputting it into cosine, it's an arc length. So I'm going to go 1, 2, 3, 4 pi over 3. So I know right where I am. There's no ambiguity here. And I'm supposed to first figure out my x value. So it's looking like I'm at x coordinate 1/2. I'm then supposed to take that x value and plug it into inverse sine. So here's one of the ones I was warning about. Yes, I got that out of cosine because it was my x. But this is a two-step process, and sine and inverse sine and cosine don't communicate about what their value means to them. So cosine says my x-coordinate is 1/2. When I give that 1/2 to inverse sine, it doesn't care what cosine said. It says, oh, my y value is 1/2. What is my arc length? So now I say I've got to picture a y value of 1/2, which is going to put me closer to the x-axis, either in quadrant 1 or 2. So inverse sine will choose the point in quadrant 1, and it will look for this arc length right here, which is a pi over 6. Okay, so that was a great one where you have to be really careful or it can get confusing because what cosine is outputting is not the same as what inverse sine is inputting. So even though I got it because it was my x value, as soon as it gets plugged into inverse sine, I'm thinking about it as my y value. So I'm going to try and talk through this one in a not confusing way. I may or may not succeed. So really what I'm being asked here, let me see. If I go to arc length 4 pi over 3 and find my x, what arc length would give me a y coordinate that equals that x? I don't know if that was really helpful at all, but thinking through it, that's what I'm seeing. So what arc length will give you a y value that's equal to the x value you got from arc length 4 pi over 3? That one maybe sounded a little better. Still pretty tricky. Okay, a few more. This is a big one. I have a whole bunch of these. Okay, so we have arc cosine of sine of pi over 2. So sine inputs arc length, which means I'm picturing an arc length of pi over 2, which is right smack at the top of the circle. So again, not ambiguous at all. That's exactly where I am. And sine will want to know what is your y coordinate. So at that point, my y value equals 1. I then need to take the 1 and plug it into arc cosine. So once again, sine was telling me my y value, but as soon as I plug that into arc cosine, these two aren't talking about what that 1 means. Arc cosine automatically assumes, it's the only thing it's able to do, automatically assumes that this is an x value. So now the arc cosine says, oh, my x coordinate is 1. What is my arc length? And the answer is 0. So let's see if I can figure out how I said that last one in a way that I kind of liked at least. So this one is saying what x value is the same as the y value you get at the end of arc length pi over 2. Okay, couple more. Let's see. Tangent of arc cosine of 4/5. Already looking at that one, I'm pretty sure that I'm going to need a little more room than I left myself. I think we'll get into having to do a little bit of work on some of these. So 4/5 isn't a special value, but what I can say right off the bat is I'm looking for inverse cosine of 4/5. So that 4/5 is representing my x value. So if I picture my unit circle, I'm saying I have an x value of 4/5, and I'm supposed to find my arc length. So this is another one where I have no idea. That's not a special value. So we can kind of walk our way through and see if we can figure out the bigger picture. So from arc cosine, I'm going to get an arc length, and I'm then supposed to take that arc length and plug it into tangent. And my final answer from tangent should be my slope. Okay, so this is saying if your x coordinate is 4/5, a little bit more than that, if your arc length is between 0 and pi and your x coordinate is 4/5. So if you're at this point right here with an x value 4/5, unknown y value, what is your slope? So you don't really have to find the arc length to know that. You just need the slope of that line right there. To get its slope, I need a rise over run, so I need to know that y value. But we've already got the skills to do that. We would use a Pythagorean theorem. So we would say 4/5 squared is 16/25 plus y squared is equal to 1, which means y squared is equal to 9/25, which means y is plus or minus 3/5. Because we're in quadrant 1, we're going to choose that positive 3/5. And then remember, what we were really going for was slope. So we're going to take the y, so here slope is the y 3/5 divided by the x, which is 4/5. So we'll multiply by its reciprocal, 5/4, and it looks like our slope has to be 3/4. So again, if you get stuck on one of these, if it's not a special value and you're going, well, how am I supposed to figure this out? Take a step back and read the entire question and see if you really need to know the arc length to answer it. Okay, let's see. Secant of inverse sine of -1/3. So if the -1/3 is getting plugged into inverse sine, it must be a y value. And then inverse sine will try and tell me my arc length. And then based on that, I'm supposed to find 1 over my x value. Okay, so let's see. If we are picturing unit circle, y value of -1/3, I could be in quadrants 3 or 4. Because this is inverse sine, it's going to choose quadrant 4. Specifically, I'm between -pi/2 and pi/2 with a y coordinate of -1/3. So again, it's not a special value. I don't know the arc length, but without knowing the arc length, I can figure out my x coordinate. And if I know my x coordinate, I can certainly find 1 over my x coordinate. So this would output an arc. I would then input the arc length into secant, and it would output, I'm not leaving myself very much room, it would output a 1 over x. That's what I'm expecting to get. Okay, so basically, given a y coordinate of -1/3, can you find the reciprocal of x? So we would say, again, Pythagorean theorem, x squared plus -1/3 squared, which is 1/9, equals 1, which means x squared is equal to 8 over 9, which means x is equal to plus or minus the square root of 8 over 3. If you'd like to go a step further and extract roots from that 8, that's fine. It does break down a little more to 2√2 over 3. I don't care either way. We decided that we were in quadrant 4, so we're going to choose, what is this? This is our x. We're going to choose the positive x. Okay, so we know that our x coordinate at this point is, I'm just going to go back to this one, √8 over 3. We were looking for 1 over x, so our answer is going to be 3 over √8. So once again, we don't actually need to know that arc length at all to answer this question. Okay, last one. Sorry for the beastly long video. The last one is the trickiest in its own way. And actually, I think the trickiness happens right off the bat. So I am trying to find the sine of the arctangent of pi/4. So if I'm plugging pi/4 into arctangent, here's the tricky part. Maybe pause and think about it for a minute so that you're really clear on this. If I'm inputting pi/4 into arctangent, then that's my slope. So I'm not saying arc length pi over 4. I'm saying my slope is pi over 4. Remember, pi is just a little bigger than 3, 3.14. So this is pretty close to a slope of 3/4. So I'm picturing, I'm on the unit circle. I have a slope pretty close to 3/4, so a little below the actual pi over 4 arc length mark. Okay, so I'm supposed to take this. So this is y equals pi over 4x, line through the origin with a slope of pi over 4. I'm supposed to take this and say if my slope is pi over 4 and I'm in quadrant 1 or 4, what is my y value? So I'm definitely going for quadrant 1. Over here, the quadrant 3 doesn't work. And I'm back to my Pythagorean theorem, but this time I don't specifically have an x or a y. So again, I hope this feels familiar. So I actually have two pieces of information I have to try and merge. I know that my y value has to equal pi over 4 times my x value. I have to be on this line. And I know that my x squared plus y squared has to be 1, so that I'm on the circle. So I get x squared plus pi over 4x squared equals 1, which means x squared plus pi squared over 16x squared equals 1. And this gets a little messy, but it's not crazy unreasonable to crunch through. It just looks a little scarier than usual. Sometimes people hate this part, so let's make that 16 over 16 so we have a common denominator. And what I get, I can't do a lot with it, but I can combine them. I can say, okay, well then I get 16 plus pi squared over 16 multiplied by my x squared, which means my x squared is equal to 16 over 16 plus pi squared, which means my x is plus or minus 4 over the square root of 16 plus pi squared. Avoid the temptation to square root the 16 and the pi squared on the bottom. Radicals don't split over addition. We can't just say square root the first part and the second part separately. Okay, let's think back where we were before all of this mess. We were sitting in quadrant 1, so our x value should be positive. Looking back at my question, I was saying if my slope is pi over 4 and I'm over on the right side of the circle, what is my y value? So I slightly did it the long way by substituting in x's. I found x, but it's pretty easy to find y from there. If I go back up here, this says that my y is going to equal pi over 4 multiplied by my 4 over the square root of 16 plus pi squared, which allows me to cancel 4's. So my answer here is pi over the square root of 16 plus pi squared. All right, so I want you guys to be comfortable with any variation of this composing trig functions and inverse trig functions. So give it a try, and as always, contact me if you have trouble. Thanks for watching.